Downtown Houston, Texas, where they never let you forget that this is the land of the gusher. Houston's energy powers America. We're here to illustrate a key aspect of supply and demand, curve shifting, which is also key to making sense of why energy prices can soar sky high. In the early years of the 21st century, Houston was home to America's booming natural gas industry. Enron, Dynegy, and competing for top billing, the El Paso Corporation.
I thank you all for joining us today.
El Paso's annual meeting with stock analysts in the year 2001. Their job, to track the company and its fortunes in order to advise investors. Understandably, El Paso was out to impress.
Particularly proud of our new trading floor and proud to be here with you on this trading floor.
Because in 2001, times had never looked better, El Paso boasted about its size.
When we went public in 1992, we had total enterprise value of $2 billion. Today, it is over $50 billion. That's pretty exciting. This is the new El Paso.
If the speech lacked a certain energy, El Paso certainly didn't seem to.
Buy 'em, buy 'em, buy 'em.
In fact, in the past year, the market price of natural gas had tripled from $2 per 1,000 cubic feet to nearly $6, and then risen as high as $50, a bonanza for companies like El Paso. To Barbara Shook, who watches the industry, several different factors contributed to the same textbook effect.
When you have a warmer than normal summer, a colder than normal winter, and increasing demand for both natural gas and electricity, all coming together at one time, you're going to have a problem. It's a simple case of supply and demand.
To illustrate, let's go to my Boston basement in the icy winter of 2001. We'll employ our old buddy, the demand curve. People wanted more gas than they had before. How do you depict more demand? At a price of $2 per 1,000 cubic feet, there are enough Americans to buy, say, 15 trillion cubic feet of the stuff. If it gets colder, there will be enough to buy maybe 20 trillion cubic feet. In fact, up and down the demand curve, at any given price, there'll be more demand for gas if the weather gets colder. Therefore, the whole demand curve will shift out to the right. My dumb memory device for this: when demand is more, with an R in the word, that means a shift to your right. And back at the original demand curve, if, say, warmer weather leads to less demand, then the L reminds me it's a shift to the left. Now, a shift in the demand curve can happen for a number of reasons. Say tastes change, and people start disliking gas because it suddenly turns out that, oh, I don't know, a fossil fuel like natural gas becomes politically incorrect. People will buy less gas at any given price, and the curve shifts left. How about if a related good like oil that can be used as a substitute for gas suddenly takes off in price? The demand curve shifts to the right, since people will buy more gas now that oil, the stuff you might buy to heat your house instead of gas, is more expensive. How about if world population suddenly begins to drop? That is, a change in the number of buyers. Population is shrinking in rural Europe, for instance. Fewer people has meant less demand for housing. If there were fewer people worldwide, it would suggest less demand for natural gas, a shift to the left. On the other hand, how about a change in income? Suppose people get a lot richer. Why, then they'll be able to afford more of everything, which means they can buy more natural gas, for any reason, to heat Montreal's St. Lawrence River, for example.
This is not warm.
Turn it up.
So which way would the graph shift in the case of more income? Right, right? Right. Okay, that's the basic idea of the demand curve shifting. So back to our story. Now, when you've got a white Christmas in the Northeast and even Frosty needs to dress warmly, you don't need a weatherman to know which way the wind's been blowing. But since tomorrow's demand for gas depends on tomorrow's temperature, El Paso had an in-house forecaster who briefed the company's traders every single morning.
High pressure's got control of the southeast, weak system here in the central plains, not much behind it.
The latest one-week forecast, very cold air continues. Bad for consumers, good for suppliers like El Paso.
Last Thursday, we had a shift to a more bullish situation, and
Bullish meaning?
colder air.
Bullish for the market,
Right.
and the price goes up.
Right. When we say bullish, we mean price going up. Now, from a consumer standpoint, that might be bearish to you, but it's a different, depends on which side of the phone you're sitting on, I guess.
Okay, so far so simple. When the weather got bad, there was more demand for gas. The demand curve shifted to the right. Meanwhile, at the very same time, there was a shift in the supply curve. Less supply at any given price, a shift to the left. Some reasons for a leftward, sometimes called inward, supply shift in the energy market are pretty clear. A decrease in the number of sellers, for example, or a decrease in supply due to war, as happened to the supply of oil when the Kuwaiti wells were destroyed in the Gulf War of 1991. Other reasons for a leftward supply shift are less easy to generate. In 2001, for instance, there was a huge leftward supply shift in electricity going to the state of California, much of it generated by burning natural gas. But gas suppliers weren't leaving the market. There was no war. Instead, a bunch of power plants supplying California had to be shut down for maintenance. And the natural gas pipelines, claiming to be overloaded, restricted their throughput. So less supply just when there was more demand. Now, here was the old equilibrium price, $2 per 1,000 cubic feet. But when supply shifts left and demand shifts right, prices shift too. In California, from $2 to $6 to $50, so high it doesn't even fit on our graph.
Hey, Robbie, did you sell any March, April? Hey, Rob sold me 400 March, April.
To the gas traders, the story lay in the dynamics of a free market.
It's that simple. It is the old-fashioned demand and supply curves that we've all had in our schooling for years.
Now, a business journalist tends to be a skeptic. You see enough scams to make you pull out your hair. So I wondered in this case if the traders weren't being naive, if the suppliers weren't in cahoots. At the time, I put the question to a stock analyst attending the El Paso meeting.
There's no conspiracy.
But think about it for a second. Let's say it's you and I, and we're running a natural gas operation. And we see prices beginning to go up to unprecedented highs. And we think, gee, if we could wait a little longer, then, and hold our gas off the market, why, that might even contribute to the price going up a little higher, at which point we could sell.
It is very difficult for the companies in the industry to rig the market because there are too many different players involved. The ability to really game the system is much less than the public generally perceives.
Given the sheer size of the industry, then, it came as a shock when the government turned up genuine instances of dirty tricks, manipulation of the energy market in 2001. But 2 years later, economist Mike Salemi had the benefit of hindsight.
The question is, how would this collusion go? Get some like-minded individuals, suppliers of alternative energy sources, and they want to see that price rise, and then they're going to divide the spoils. Well, one thing you do is got to cut back the supply. You got to get the people in that range where demand equals supply at very high prices. So you schedule routine maintenance for an awful lot of electric generation facilities. Or
They did that, and that was done.
That's why I say it. Or you take some pipelines out of service, or you do a variety of other things. You commit the gas elsewhere or something. I'm not an expert on energy economics, but you don't have to be to understand that the collusion would take the form of a limitation of supply.
In fact, the hottest of Houston's hot energy firms, Enron, pleaded guilty to overloading power stations, which then had to restrict the supply to prevent themselves from blowing up. As for El Paso, by the start of 2004, it was down from $50 billion in enterprise value to less than $30 billion, and had paid $1.5 billion to settle a federal price-fixing case. More importantly, though, despite new 3D imaging technology to make gas easier to find, America was producing less and less of it, year after year, using more and more gas, and as we finished this narration, the price of gas was back up over $7 per 1,000 cubic feet. So the moral of this story is not just short-term, But long-term supply and demand shifts have been keeping natural gas prices aloft.